All right. Well, test one is over, so you have an idea of how I test and what to expect, I guess, a little bit. Um, let's take a look real quick at the grade distribution. I was actually pretty happy with this. Um, make it a little smaller so we can see it. So these are broken up by 10 points. So this A's, B's, C's, D's, and then everything from here on are F's. So the green are passing, the red are not passing. So we had what, 14 passing grades, 10 not passing? But even with the 10 not passing, this is actually a pretty unusual distribution for grades. I normally don't see this. What I normally see are lots of A's and B's, not a whole lots of C's and D's, and then lots of lower grades. So what this kind of, I guess, to me means is that there's a smaller window of distribution of grades, so smaller standard deviation. I did compute the standard deviation. The average in the class was a 71. Standard deviation was 17 points. What did y'all think? What did you all think? Any comments? I won't hold it against you. Any? Did you feel like it was a fair test? I know sometimes you come out of tests, you're like, what the hell was that, man? You know, I didn't. That was nothing like anything we've done. You know. Okay. The one with the squiggly on the picture one got almost everybody. I don't think that limit doesn't exist. You got, but it's not headed the if it bounded over infinity, it would have done that. But off the picture, it was just oscillating. So there was a video that I did do, one of the videos that you're supposed to watch before class, that did have an example of that and me showing that it didn't exist. So, what's that? And also, like, just the sine function up and down. So, what else about this? Lowest grade was a 27, highest grade was 100. There was a bonus, right? So nobody got everything right and the bonus. Which, the class average being 71, what do you all think of that? I mean, everything's downhill now. No. I actually think 71 is decent for an average. Yeah. The thing is, we have to talk a little bit about, you know, what letter grades mean. Like, you know, what is a letter grade? What's an A? What's a B? What's a C? Right? Normally, college, the way A's, B's, and C's are meant to represent is a C is average, right? C is average. If you hold a C, you know, C grade point average in a C range, that means you're average. You're with the rest of the group, so to speak. B means above average, and then A is exceptional. So when we have a few exceptionals and a few above averages and a lot in the average area, right, then this is a pretty good distribution. If the class average is average, then, you know, it's a little low, but it's, I was pleased with the results. The tests are up here. If you're coming in, tests are up here. Just come grab them. I was asked about makeup tests or bonus or anything like that. I don't normally allow makeup tests, so, you know, every test, be prepared that that's going to be the grade you get. So there's no mulligans, I guess. Was it -1? Yeah, on the bonus ones, I give maybe sometimes I give a little bit of bonus if you're doing the right thing, but usually it's like yes or no. You got it or you didn't type grade. I don't know. 6 points? But that's 6 out of, the test was not out of 100 points. Let me see it. Oh, I'll look at my key. I believe it was out of 78 points total. Where's my, let's see, 10, 28, 38, 43, 55. It was out of 79 points. There were 79 points possible. So if yours says like, -5, but you didn't get a 95, it's because it's out of 79 points. All right, I want to also say I apologize if anyone had come by my office this morning or went to go reserve office hours. I had canceled them for today because I wasn't feeling good this morning. I'm feeling better now, so that's why they were canceled. I apologize, but I should be in my office tomorrow, no problems. Today, I think after class, I'm going to head out. I'm going to go home just to get some rest because, I came this close. I had the emails like ready to go, ready to click send to the class today, like class is canceled. And I sat there and I said, I think I can make it through this. And yeah. Yeah, I look terrible. Thank you. Appreciate that. Well, you can watch the video I'm about to make. All right, now we're going to go ahead and pick up in 2.1. And if you watch the video for 2.1, like you're supposed to before you come to class, I'm not going to go through the whole thing. I'm just going to get to the very end of it, which is the whole idea of this section 2.1 is trying to come up with a way of determining the slope of a tangent line on a curve. So if we have a point that we pick on a curve, and we pick some x value a, I don't know if y'all can make that out, but the x value is a, then the height of that point is f of a. It's whatever the function is evaluated at that point. So this point right here has the x and y coordinates that are a, f of a. Then we pick some other point on that curve. All right, we pick some other point. And we connect those 2 points with the line. And we can find the slope of that line by using rise over run. If we move that second point closer and closer and closer and closer to that first point, we begin to get really close. A slope, right? This slope of this line is starting to approach something, right? And then once it gets there, we finally have one point right on top of the other. And when that happens, we no longer have a secant line. We have what's called a tangent line. Now, the problem with the tangent line is that it gives you the 0 over 0. So the way around that is to use a limit. Well, I don't want to zoom in. And here's the actual formula right here. This limit x approaches a of f of x minus f of a over x minus a. That right there is what we are going to compute to find the slope of the tangent line. If this section is about anything, it's about that formula right there. And then the rest of this is how you find the equation of the tangent line. So there's two main ideas today. How do you find the slope of a tangent line? Then, how do you find the equation of the tangent line? So I'm going to start working some problems. These are the two formulas right here. There's two versions of them, these two. So I could have given a quiz today, right? I could have said, what are the two, give me one of the two formulas that give you the slope of the tangent line. Those are the ones. You should probably have those hardwired by the end of the week, all right? Like in here somewhere. All it is difference quotient and then the limit out front. Difference quotient, limit out front. All right, so let's get to some examples because today really is about examples. That's all we're going to really do. Today we are in day 7, huh? So I'm gonna just pull some problems out of the book that are similar to the ones like in your homework. I'll just do some of the evens, and that'll leave you with some of the odds at home. All right, here we go. I'm going to do number 2. It says find slope tangent line to the curve y equals x minus x squared at the point (1, 0). So here's what I'm going to start with, okay? I'm going to go close this window as soon as I let everyone write it down. I'm going to go to my little wind plot program, and I'm actually just going to graph this real quick. It was x minus x squared. I'm going to have it make it kind of thick so we can see it. It's a parabola, and we want to look at this at the point 1, 0, which is right there, isn't it? We want to find the slope of the tangent line. So there's some line that runs tangent on this curve. It has a slope. Do y'all see it? Can you see it mentally? Do y'all see the tangent line? I can bring it in here. Tangent. Somewhere about right there, right? Does that look right to you? I want the slope of that line. Now, according to what this computer appears to be doing, it looks like it's already given me the slope as -1, right? But we'll have to be able to do that by hand. Now, if I move to a different point on the graph, like if I move to the origin instead, come on, there, then the slope changes, doesn't it? So at different points on my curve, my slope is changing. It's different. Agreed? We just want the slope at one particular point. Any questions on what we're doing, the visual representation of what we're doing? Okay. So to do this, to find the slope of the tangent line, I'm going to put m tan. Now, I'm going to put m tan just so everyone understands that this is the slope of the tangent line. Later on, I'll throw away the tan, and we'll just say slope, slope, slope. We'll say m, m, m. Okay, this should be one of two things. The limit as x approaches a of f of x minus f of a over x minus a, or limit h approaches 0, f of a plus h minus f of a over h. In both of these problems, whether or not you use this formula or this formula, okay, you get to choose. So you have the freedom of choice here in which one to use. And sometimes the first one's easier than the other one, or vice versa. Sometimes they're about the same thing. Now, what you do have to recognize in both of these problems is, what is the A? we'd like to replace that a in the problem. And a is always going to be the x-coordinate of your point. So for us, this is going to be a is equal to 1. Are y'all okay like that, writing backwards like this? Y'all want to like turn the desk a little bit or something? You're okay? I'm not going to force you, but I mean, all right. All right, so let's choose here. Formula, option 1 or option 2? Which one? 2? All right, we'll do 2. Why? Why? Because someone said 2, so let's do 2. So here's what I'm going to use for this particular problem. I'm going to go, the slope of the tangent line is the limit, h goes to 0, f of what? Replace a with 1. So 1 plus h minus f of 1 all over h. Now, we've actually done this before in this class, right? This right here is the difference quotient. So we're going to go figure all that out, and then at the end, we'll take the limit, and we'll let h go to 0. But we've got to be able to figure all the difference quotient out first. So let's talk about this f of 1 plus h. This means I'm going to plug 1 plus h into the function f. Here's my function f, right? Actually, it's written y up here, but I could replace that y with f of x, right? So f of x is x minus x squared. I'm going to replace the x in this with 1 plus h. So I'm going to try and write this all in one line. It's limit, h goes to 0. It's, what was it? 1 plus h was x. Then what? Minus x squared. Minus x squared. So minus 1 plus h, what? Squared. This right here, right, that is just this part right here. Y'all agree? That's just that one piece. Then I still have to do what? Minus f of 1. Minus f of 1. What is f of 1? It's just 1 minus 1 squared. 1 minus 1 is 0. So this just turns out to be 0. That's nice. Now, if you wanted to, you could on the side have written this out. You know, f of 1 is 1 minus 1 squared, which is 0, if you wanted to. Or just do it mentally. All of this is over what? H. Okay, so I'll match this stuff up. Here's our blue part. Here's our blue part. Yes. Yes. Good question. No, because there's no parentheses around the negative. So when you look at this, this is actually, this right here is actually x minus 1x squared. And what you're doing, order of operations, that's multiplication. This is 1 times this. Order of operations is exponents before multiplication. So you square it and then make it negative. The only way that would have been square the negative also is if it would have been something like, that means you square the negative. But you would have to have the parentheses there. All right, now we have to do some expansion. Limit h goes to 0. 1 plus h. Now here, 1 plus h squared. What's 1 plus h squared? So you do that maybe on the side. That's what 1 plus h squared is, right? You have to FOIL it, don't you? 1 plus h, 1 plus h. It's Monday, so I'm taking my time through this. All right, but I'm going to stop showing this work at some point. All right, this is what we're doing. We're squaring it. We're expanding it. We are collecting like terms, and we're going to put it right here, right? But it gets subtracted, doesn't it? So I have to distribute a minus sign to each of these terms. So what really is going to go here? Minus 1, minus 2h, minus h squared. And that 0 at the end is gone, all over h. Now remember when we were doing difference quotient, what was the thing we were really hoping that would happen? That we get a canceling of the h. Well, we can't cancel h's yet, not until we realize that the 1s are going to go away, right? And now we have limit h goes to 0 of negative h minus h squared all over h. So I just combine the plus h and negative 2h together, right? That's negative h. And then minus the h squared. Now everything has an h, so I can factor an h out of the top. An h, right? Hey, look, my limit has come along for the ride. I really actually was very pleased with how well, as a class, y'all did keeping your limit the whole time until the very end. I think it's one of the best group of tests I've had from a class in a long time with notation on the test. It was really good. So pull an h out, what's left? Negative 1 minus h, right? Be careful with the sign there, right? Because we pulled a positive h out, which leaves these signs as negatives. And now cancel the h. And final step, we're going to take the limit as h goes to 0 of whatever's left, right? I have negative 1 minus h. And this limit is just let h become 0, right? If h is 0, what's the only thing left? Negative 1. So no more limit. That's my answer. And doesn't that match with what the picture had said we'd get? Negative 1. It's because it's going to 0, right? Like if this was going to something other than 0, then this would not go away. All right, what do y'all think? So it's difference quotient, which we've done before. It's some limits, which we've done before. And now we're just kind of putting them together to get this slope of this tangent line. Now, the next part of this problem, so the problem continues on. That was part A. Part B, it says find the equation of the tangent line at that point 1, 0. So if you were looking at this problem, I guess from a broad perspective, we've done the calculus. Okay, the calculus part of the problem is done. We found the slope of the tangent line, right? Now the rest of the problem is a college algebra problem. We are trying to find the equation of a line, right? They give us a point. The point is the point 1, 0. The only thing we need to define a line in college algebra is a point and the slope. But we just got the slope in part A, didn't we? So we have right now, I meant to say we have a slope. Notice I'm not putting tangent, I'm just putting slope. That's equal to negative 1. And we have a point 1, 0. The equation of a line can always be written y minus y1 equals m times x minus x1. We called that our point slope formula because it gives us the equation of a line if we know the point and the slope, which is what exactly we know. So for us, x1, y1 are given to us with those 2 points right there, those 2 numbers, 1 and 0. And our slope, of course, is m, is negative 1. So just rewrite the equation. We should get y minus 0 equals m, which in this case is negative 1, and then x minus 1. And that is the equation of the tangent line. But I think you should get used to taking that equation and converting it into this form. Remember this form of a line? Y equals mx plus b? It's called the slope-intercept form of a line. Basically, you're taking this equation and solving for y, which shouldn't be too hard because that 0 on the left side, That just leaves it as y, doesn't it? And then distribute your -1 through. You get negative x what? Plus 1. Questions? What I'd like to do is go back to this program where I had shown you this. And I had moved this over to 1, right? And that the computer was able to tell us this right off the bat, right? I mean, we pretty much had that, yes? But what if I take this out of here and close this out and act like I didn't know that, and then have this little thing graph the line we just found. The line we found was y equals negative x plus 1, right? So if I type negative x plus 1, I'm going to have this graph it. I'm going to have it graph it in blue. And I'll know I'm right when I see it, okay? That's it, right? That look like the tangent line there? So I feel pretty good that we found it. All right. Questions, comments? No, you would just type those two into your calculator, x minus x squared, and you would type in negative x plus 1, and you would graph them, and then you would just have to convince yourself that that looks like the tangent line. I mean, if you did it, and let's say you had forgot to distribute that negative, you know, and you would have got instead of negative x plus 1, you would have done negative x minus 1. Then when you graph that, you're going to know right away that you're trying to go through that point, right? It's pretty obvious that that line's wrong. So something's off. Or if you were to do it and go, something like that, right? Like it looks like your slope might even be off. Or like that. I mean, you're obviously wrong. Okay. Right. Part C of this problem says graph it with the graphing calculator. You don't have to do that part of this. Just be aware that you can do it. All right, let's do something a little more challenging. Find equation of tangent line. This is an example. I'm making up this example. 2y equals 1 over square root of x plus 2 at two, 1. Oh, wait, hold on. 2, 1/2. My apologies. All right, so in the last problem, they broke it up for us. Part A, find the slope of the tangent line, right? Part B, find the equation of the tangent line. Here, it's just us find the equation of the tangent line, right? Which means we have to do basically the part A and the part B from the previous problem in order to achieve this. So the first thing I'm going to do is find the the slope of the tangent line. And I can use either formula. So I'm going to write that down first. I'm going to try and find the slope of the tangent line. What is our A in this problem? A is 2. So I'm going to mark that right now. A is 2. We have limit x approaches A, right? Which, can I put 2 now? Of f of x minus f of A, which is 2, all over x minus A, which is 2. Or we could use limit h goes to 0, f of A plus h, 2 plus h, minus f of A, which is f of 2, all over h. Any requests on which formula to use? You want to do the first one this time? Any particular reason why, or? Okay, so since we've used the other one, you want to just try the other one? Yeah, try the first one? Okay. All right, here we go. So we're not going to do this one. So what are the things that we need in order to figure this out? Well, we need to know what f of x is. Do you know what f of x is? Yeah, it's just 1 over square root of x plus 2. See, for using this formula, it's relatively easy to figure out that first part, right? Because you're just going to write down exactly what's here. On this one, you have to plug in 2 plus h in here, don't you? That can be a little more complicated. And then f of 2, same thing, right? So let's just see where this goes. This is equal to limit x goes to 2. All right, f of x was 1 over square root x plus 2 minus, now we get to plug in, what is f of 2? Now hold on, before you get ahead of yourself here, f of 2 means I plug 2 into the function, right? What does this point mean? What does that mean? It's supposed to live on the graph, right? So doesn't that mean when I plug in 2, this is what comes out? So isn't that f of 2? Well, just check it though. 2 plus 2 is 4, square root of 4 is 2, 1/2, right? So you could actually get this f of 2 from that y coordinate right there if you wanted to. Just pointing it out that it was that, you know. It shouldn't be too much of a headache for us to actually just plug 2 in. And then x minus 2 on the bottom just stays the same. Now, with the formula that we used in the previous problem, right, we wanted the h to cancel at the end. Here we want what to cancel? X minus 2. This whole thing we want to cancel. But we got that big old cluster up there, right? We've got a complex fraction because we have fractions on a fraction. Then we've got radicals. You love radicals. So whenever you have a complex fraction, what was it that I suggested you do? Get a common denominator, right? Put these together. Try and put those together. And then we'll come in with conjugate later. But we got to put the fractions together before we come in with conjugate. So what do I need to introduce? If my common denominator are both of these pieces, right, this and this, I'm missing a 2 on top and bottom here, right? And I'm missing the root x plus 2 on top and bottom here. So here I come. 2 is going to go on the top and bottom. Over here, root x plus 2 on top and bottom. And that gives me a new limit. All I'm doing is rewriting this, you know, putting the 2 on top here and the root on top here and combining those. Now I'm going to put them together so that I have one denominator. So it's 2 minus root x plus 2 over that common denominator, 2 times root x plus 2, all over the other denominator, x minus 2. So I've taken the complex fraction that had two fractions being subtracted, I put them together into a single fraction, and now can you see the conjugate that we're going to need? We have 2 minus root x plus 2. The conjugate would be 2 plus root x plus 2. I guess the question would be, where do you put it? Because you have to put it over itself, right? You actually have two options. You could go right over itself right here. That would be okay. Or you could actually put this as like a 2 over 1 and then put this thing right here down here. It doesn't matter. You'll get the same result. I'm going to do it exactly like this because I have a fraction. To me, it makes most sense that that's a 1 sitting right next to it. So that's the way I'm going to do it. Questions? Equals limit x approaches 2. What's that conjugate going to give us here? Remember, the middle terms go away. So 2 times 2, 4. Middle terms are gone. And then I have a negative times a positive, which is negative. But then the root times the root, those roots should go away. And you get x plus 2. But remember, we had a negative there. So I better put it in parentheses, x plus 2. Over what? The common denominator we had, right? But what else did we put down there? That conjugate down there, right? So this right here is this. Then I multiplied by the conjugate, so I need to put that conjugate down there, and I need to put it in parentheses because it's two terms, right? Whenever you have two terms next to a factor, you have to put in parentheses. But all of that's still over what? X minus 2. Now distribute in the numerator the negative through. And we have, again, I'm writing the limit. X goes to 2. What do I have up there? 2 minus x? Seriously? 2 minus x over all that crap down there. All over x minus 2. I'm a little disappointed. Why? They don't match exactly, right? I'm wanting those two to cancel, but they're off, aren't they? But they're off by just a sign. This is positive 2, that's negative 2. This is negative x, that's positive x. So they're off by just sign. What do we have? What can we do when they're off by a sign? Was it? You factor out a negative 1. You can factor out a negative 1. You can factor it out from here or here. It doesn't matter. I'm going to do it from the top. If I factor a negative 1 out, and I don't want to rewrite the whole limit, I'm just going to cancel this, and right above it, I'm going to pull a negative 1 out. How would I have to rewrite that so it's the same thing? I need to get a positive 2, so what would I need to put here? Negative 2, and then if I need my negative 1 to multiply and give me a negative x, so positive x. But that's the same as x minus 2. Isn't this the same as x minus 2? And now they perfectly match. And I can cancel them, but that negative 1 had to pop out. Yeah? Any questions? I'll give you a second to jot that down. I've got to go to another page. I'm still in the limit, okay? I haven't taken the limit yet. I'm about to do it, though. So I'm at limit x approaches 2. I had the negative 1 on top. Then that was over 2 square roots of x plus 4, right? No. x plus 2, and then times, in parentheses, 2 plus root x plus 2, and that was it, right? I had that thing, it canceled on the bottom, it was just a 1 down there, so now I'm ready. Let x go to 2. Let all your x's become 2's. No more limit. Negative 1 over. We should not get division by 0 now. 2 square root 2 plus 2 times, in parentheses, 2 plus square root 2 plus 2. Two plus 2 is 4. Square root of 4 is 2. So this is equal to negative 1 over 2 times 2 times 2 plus what? 2. Y'all keep up with that? This right here is a 2. We had a 2 out front. This up here, this right here is 4. Square root of 4 is 2. So what do we have here? 2 times 2 is 4. 4 times 2 plus 2 is 4. So negative 1/16. All that for negative 1/16. So if I were to graph this, right, if I were to actually graph this curve and go look at the tangent line at that point, it should have a slope of negative 1/16, which means it's not flat, it's got a slight tilt, right? Left to right, it goes down just a little bit. With me? That's just the slope, though. I have not done what yet? Found the equation of the line. That's just the slope. So now I go find the equation of the line. The equation, I have the point, don't I? I have the slope, negative 1/16. I have the point. The point was given to us in the problem, right? 2 1/2. And so I go to my point slope formula for a line and replacing things. So y minus, what's y1? 1/2 equals m, negative 1/16, x minus 2. Now, although that is correct, on the test, I will ask you for the slope. I will ask you for the equation of the line in slope-intercept form. So I will always require you to go the additional step of solving for y. So just get used to the next few steps. The way I like to do it is this. I like to distribute that through first. Leave that 1/2 alone for the negative 1/2 over there. I get negative 1/16 x. You all right? Did you just fall? All right. That's funny. Negative 1/16 x, and then negative 1/16 times negative 2 is going to be positive 1/8. All right. Now I'm going to work with this 1/2. Negative 1/2. I'm going to add it to both sides. So I'll have y equals negative 1/16 x. I had a plus 1/8, and now I'm adding a 1/2. I hope we're all comfortable with the idea of just adding 1/2 to both sides of the equation to make it go away, right? What's 1/8 plus 1/2? 5/8. So you have to get a common denominator, right? Do all that stuff. 5/8. That's what those two together. 5/8. That's 1/8 plus 4/8. Okay. All right. Time to check my work. You ready? All right, so I'm going to come over here, and I'm going to say, please graph for me. The original problem was 1 divided by the square root, so you put SQRT, square root of x plus 2. And I'll make that a little bit larger so we can see it. There it is. I also want to graph my slope, or my line, which was negative 1/16 x, right, plus 5/8. Now, what should I see here when I do this? What am I hoping for? For a line, right? What point does that line need to pass through? What point? 2 1/2. So here's 2, here's 1/2, right? That looks right. Okay, 2 1. I should get a line that goes through that point and is tangent to this. So it's not going to look like that, right? It needs to look like, I don't know, somewhere right around in there. Feel good about that? I feel good about that. That looks like it goes right through there. The odds of you getting it that close and being wrong are pretty rare. I mean, usually if there's a mistake in a sign or something, it's not even going to be close. That's pretty much dead on. All right, got it? Now, let's say now that I said, well, wait, hold on, I forgot. That's not what I really meant. I wanted you to actually find it at 7 1/3 instead. Is 7 1/3 a point on that graph? Plug in 7 right here. Get 9. Square root of 9 is 3. You get 1/3, right? So that point does live on the graph. Oops, sorry. That's not what I meant. I meant this instead. What would you have to do? You have to do the whole process over again, wouldn't you? This time A would have to be what? A would be 7. And what if I said, you know what? Oops. I actually wanted another one. You'd have to go through the whole process again, right? So maybe there's a way that we can actually figure out what the answer would be at just an arbitrary or just a general point where I'm not specifying exactly what A is, but you can get me a general answer, and then later on you plug the A in at the end of the problem instead of at the beginning and having to work through it. Does that make sense? I mean, asking you to find the slope of the tangent line at one point is very mechanical, and there's a lot of algebra in it, and you get to a result. But then if you ask another point, you have to do it all again. So how about let's approach the same exact problem, but this time at an arbitrary point, right? And you're going to see the power of this, doing it this way as opposed to the other. So now I'd like you to find the slope, not the equation. I'm not going to make us work all the way through it. Find the slope tangent line to y equals 1 over the square root of x plus 2 at x equals, where do I want it? Or sorry, at, I'll just say at 7 1/3, but I want it to be arbitrary. So I want the A to be, no, I don't want to fix the A. You see what I'm saying? I don't want to tell you what A is, because then if I give you A and I give you a different A, you have to go redo everything, right? So instead, why don't I just say at A and whatever the function's value is at A? Like just this, the point is that I'm going to be letting my A be arbitrary. I'm going to let it be A. I'm not going to tell you what the value of A is. Can you still compute this? One of these two. Can you still compute these without actually knowing what A is? Well, let's see what happens. What's the slope of the tangent line? Well, let's use the same formula we just used, which was this one, because we're familiar with the algebra in that, and I can move a little quicker through it. What would f of x be? This time we're saying limit x approaches a, right? I'm not telling you it's 2 or anything like that. F of x, what's f of x? 1 over square root a plus 2, hold on, x plus 2, right? That's what f of x is, minus what's f of a. Now it's 1 over square root of a plus 2 all over x minus a, and I don't know what that is. See, this is a very similar setup to what we just did. The thing that sucks about it is in the previous problem, we knew what a was, so we knew this turned out to be like 1/2, right? And over here, we knew that that was a 2, so now we don't know what that is. It depends on what a is, right? But can we still go through and do all the algebra required? Well, we have a complex fraction, right? We've got radicals, so I'm going to collect these two together, get a common denominator. So this one has a root x plus 2, this one has a root a minus, or root a plus 2, so I'm going to have to introduce each one to the corners and down, right? So it's going to look like this. I'm going to come in here with the root a plus 2 on top and bottom. Over here on this one, root x plus 2 on top and bottom. You might be sitting there going, I understood what he was doing when he was letting a equal 2, and that was fine. You know what? I'm just going to stick to that. I don't care if I have to do it several times. But trust me, this is the way we're going to be going, okay? I'm going to be asking you for the arbitrary answer instead of the exact one at a specific point. All right. Limit. What we got? Let's put it all together. Root a plus 2. What would be, I want us to put these together now. Minus square root x plus 2 all over what? We can do it either way, x plus 2 times square root a plus 2. And I would just leave those apart from each other at this point. Don't try and put them together. Then all of that over x minus a. All right, so we brought the two fractions together now. What have we always done at this point when we got those radicals up there? Conjugate. So I'm going to conjugate the top one here. It's that with a plus between them. And I'm going to do the same thing I did last time. I'm going to introduce it on the top and bottom right here. It's plus instead of minus. Am I doing that right? Does that look okay? Now, when I multiply out the top, I'm going to be foiling those, right? So I'm putting them in parentheses. And on the bottom here, be careful. There's a huge difference between what's happening in the red and the green there. These two are multiplied together, so they're factors. These two are added, so when we put those together, we want to make sure we leave that parentheses there later. All right, let's multiply through this top. Here times here. Yep, limits coming along. A plus 2. Middle terms are gone. The last one is this and this. So it's going to be x plus 2, but we're subtracting it, right? Can I go ahead and subtract now, or do you want me to do subtract and then parentheses? Subtract now, so it'll be minus x. It's going to be minus x plus 2, right? That's what it's going to be? But then I'm going to distribute the negative through right now. So minus x minus 2, is that all right? Okay, that's what I'm getting at, all right? Then all of this over my nasty old denominator there, root x plus 2 times root x plus, no, a plus 2. In parentheses, root a plus 2 plus root x plus 2. Who made this stuff up, man? all over x minus a. This is a fairly difficult problem to give you here as one of our first examples in class because the algebra of this is messy. The problems, that you'll have on your homework, I think, will be a little bit better than this. We'll see. All right, what's happening upstairs there? 2's cancel. If I cancel the 2's, what am I left with? I'm going to write it over here on the side. A minus x. Is that going to cancel with the bottom? No, but it's off by a sign, right? So I can factor a -1 out of that. It'll become negative a plus x. But that's the same as x minus a, isn't it? So I'm doing that on the side here. This is my little scratch work. Just kind of thinking through what's left here. So this whole top really becomes what? -1 times x minus a. I'm just doing that to save myself having to rewrite the whole thing. And now I'll cancel these. Which leaves me at the last limit that I'm going to have for this problem, limit x approaches a, of, what's on top? -1 over, all that crap again, square root x plus 2, square root a plus 2, parentheses, square root a plus 2, plus square root x plus 2. Yeah. Are we ready for a limit? You ready to do it? We're going to be letting what become what? X is going to become a, all right? Everywhere I see an x, I replace it with an a. This will become root a plus 2 times root a plus 2 times the quantity root a plus 2 plus root a plus 2. And no more limit, right? -1 over root a plus 2, root a plus 2, parentheses, root a plus 2 plus root a plus 2. Now that is an answer, but I'm going to clean that up a little bit. What's root a plus 2 times root a plus 2? Just a plus 2. So I have -1 over, I have an a plus 2. Now I need to put that in parentheses because I'm multiplying that times what over here? Root a plus 2 plus root a plus 2, not times. So 2 of those, right? 2 root a plus 2's. Now, in the back of the book, it would probably have an answer like this. Now, this problem wasn't in the book, but if there was a problem like this in the back of the book, this is what they would probably have. So the 2 just comes out, right? 2 comes out. 2 is 2. But they would take, I'm going to have to go to another page to show it. They would take a plus 2 times root a plus 2 and write that as a plus 2 times a plus 2 to the 1/2. And since these are multiplied together, they have the same base. We add the exponents together. 1 plus 1/2 is 3/2. So that would become this right here. Now, that's our answer. What is great about this answer is that now, what was A in the problem we did before? The first one that, not the first one, but the example right before this. It was, that was the second one I wanted you to do. This one right here. The first one we did, A was 2, right? It was the same function. So now what I'd like for you to do is go to the answer you just got and plug 2 in. And you know what? Plug it in here because it might be easier to work with. Plug in 2. What's 2 plus 2? 4. And then over here, 2 plus 2 is 4. Square root of 4 is 2. 2 times 2 is 4. So 4 times 4 is 16, negative 1/16. Got it? But now, what if I wanted you to do the other point where it was 7 1/3? You don't have to go through all that work again. You just plug in 7 here. So you get what? 9. Then you get 7 here, 9, 3, 6. 9 times 6, 54. So negative 1/54. And if I gave you another value, you could do it, just plug it in. And now you can spit off 100 answers without even having to go through all the computations. So you have to suffer a little bit more with the algebra, but your answer is much more powerful than before. Got it? And this right here is what we are going to refer to as the derivative of the function. The derivative. It's a huge thing. If you ask someone, you know, that's in Cal 2 right now, hey, what's Cal 1 about? They're going to say the derivative. That's what Cal 1 is about, the derivative. So that's our ultimate goal, is to be able to do that. And then we'll see what we're going to use it for. All right. What are some other things that I want to get out of this section? I'm kind of on the fence right now. Should I give you a problem to work in groups in class on, or should I show you another example? You want to do a group? How about I do this? How about we have 40 minutes left. How about I show you one more example? Because right now I've given you a polynomial, right? The first one we did, this was just a polynomial, right? The one we just did after this had a radical in it, and it was a radical in the denominator, and that was pretty ugly, as we saw. Now I'd like to give you a rational function, show you how to find its derivative, and then I'll let you work on some, all right? Okay, so here we go. Trying to remember if in my lecture notes did I talk about it? Okay, yeah, right here, one of the last notes in 2.1 of the video that you were supposed to watch says, since we use this so much, okay, since we do this so often in math, what we do is we have this new notation where the original function is f of x. If you see someone write f with this little mark here, that's called the prime mark, f prime of a is called the derivative of f at a, or f prime of a. All right, so from now on, if you see me write this, it means I want you to do limit h goes 0, blah, 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 or limit x goes to a, all that stuff. It's just a shorter way of me saying, find the slope of the tangent line up to the curve, blah, blah, blah. Got it? So given f of x equals 2x plus 1 over x plus 3, find f prime a. Nope. See, that's the thing. We're now doing this in general. So like on the previous one, we said instead of letting a be something, we're just going to let a be a. Here, we're going to let a be a again. So which formula do you want to work with here? You want to do the h one or the x to a one? X to a, okay. So I'm going to say that the f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. We already talked about Kill Bill, right? The Kill Bill scene. Did we talk about the Kill Bill? You know, the movie. It was that when she's training, when she's training with that dude up in the mountains, right? And she's like, she wakes up in the middle of the night and she's like punching the wall. I want y'all to like wake up in the middle of the night and be like, limit x goes to a. You know, like this should be like automatic. You should be doing it so much it just be, you know, you should be sleep talking that formula. No? Is that too ambitious? No? All right. You need to know it though, all right? All right, well, let's set it up. Limit x goes to a, f of x. Y'all like this one because you don't have to do that a plus h in there, right? Okay. Minus what? F of a, which would be 2a plus 1 over a plus 3. And you like that because all you're doing is replacing x with a. And then on the bottom, x minus a. What do we do? Common denominator. All right. So I need to put some stuff here and here. What goes top left there? A plus 3. Over here, x plus 3. And now we put it all together. You see how the algebra is going to be a little bit different in this one? Look at this. You have to multiply a plus 3 times 2x plus 1, don't you? And then subtract what you get when you multiply these two. That means you have to FOIL those, don't you? So, I mean, you might want to throw parentheses around those to remind you have to FOIL that. So let's go ahead and do this. A times 2x, 2ax. A times 1 is a. 3 times 2x, 6x. 3 times 1 is 3. So that was just the top left of this, right? Then I have minus what I get when I multiply these two together. So I have 2ax, right? Then I have plus 6a, then plus x, and then plus 3. So what I did is I did this FOIL right here real quick in my head, and I just put it right there. Do you agree with it? I went kind of quick. Do you all agree with this? But then this is subtracted, isn't it? So you must pass that minus sign through all the terms there. Which is why down here I'm going to put minus 2ax, then what? Minus 6x, then, or no, 6a, and then minus x, then minus 3. All of this over our common denominator, which was a plus 3 times x plus 3. All of that over x minus a, which is what I'm hoping to get to cancel, right? Do good things happen up there? Let's see, 2ax gone. Oh, I see 3 and 3 are gone. That's it. Man, that sucks. So let's see, limit x approaches a. I have a plus 6x, right? Minus 6a minus x all over a plus 3, x plus 3 all over x minus a. What am I trying to get to cancel? X minus a. But look, oh wait, I could put those. Is that what y'all were saying? Oh, I didn't see that. Let's erase that line. That should be what? Can I write 5x minus 5a? Oh man, it's going to work out nice, isn't it? Because all I have to do to get this to be an x minus a up there is to factor out a 5 now, right? So we just combine like terms, right? 6x minus x, a take away 5a. That gave us that. I'm gonna just cancel this real quick and write 5 parentheses x minus a. I get my cancellation here, and I like it. What's on top there? 5 on the bottom. A plus 3 times x plus 3. And since we got cancellation, we can now let x approach a, or let x become a. So that's just going to replace that with a, right? No more limit. 5 over a plus 3 times a plus 3 is a plus 3 squared. And that right there, my friends, I'll just call you friends. We don't have to really get into that. That, my friends, is the derivative, okay? That's a lot of work to get to that, right? Now, we are going to have shorter ways to get to this answer. There's going to be shortcuts. There's going to be formulas. You're not going to have to take the limit for the rest of the semester. But you have to suffer through the limit for a while. We're almost done suffering, all right? We are one more section away from leaving the limit behind and getting rules. And so I think you'll be happier with the rules. We'll see. Now, let's see if you've lost focus on what this is all doing. I'm going to start a new problem. I'm not going to work through it all, but I just want to see if you are connecting the dots here. Find equation, tangent, line to fx equals, what was that curve I just had? 2x plus 1 over x plus 3 at the point 1 3/4. What do you need in order to find the equation of a tangent line to a curve? You need the slope of the tangent line, right? Which is really the derivative there, isn't it? It's the derivative at that particular point, the derivative of the function, because the derivative is the slope of the tangent line, right? So what I really need to know to find my slope is I need to find the derivative at what value of a for this particular problem, for what value of a? 1, right? But we just found a general formula for it, didn't we? I mean, that exact function we just did, the formula we found was 5 over a plus 3 squared, right? That's what we found? So if I want to know the slope of the tangent line at 1, all I need to do is plug 1 into the formula right there, and I get what? 5/16. Right? And now I just do my y minus y1 is 3/4 equals 5/16 times x minus x1, which is 1. And now there's my equation, right? Using that point, using the slope. A lot of work to get to that formula, but now it's just, I could knock out equation lines all day long if I wanted to. All right, here's what I'd like for you to do for your homework. And we're going to do some in-class problems. I'd like for you to do, so forget what's on the homework assignment page. Do 1, 3, 5. Seven, A, and B. $21. Ooh. 23. Two more. 27 and 29. That's a lot of work right there. Okay, so what I'll do is I'll try and make your life a little bit better. I'm going to give you a couple of these problems right now for you to do. That way you can practice. But you'll be accomplishing something at the same time. So I think, why don't we do 29. I'll write down what they are if you don't have them. Let's see, we have about, 35 minutes? See how much of those 3 problems you can do. Does every table have at least one book so y'all can share? I would start with number 1, then go to 5, then to 29. I don't think you'll finish all these problems before the end of class, but let's see how much you do. I'll give everybody a 100 on a quiz grade for participation, but you got to be working, okay? That's, what's that? 1, 3, 5, 7B, 7A, 7B, 21, 23, 27, 29. Bill, got it? I'm going to put that in there. All right. Get going. See what you can do.